In February 1943, German tankers captured an almost intact American M4A1 Sherman tank after a battle in Tunisia. The machine was called War Daddy II and became a real revelation for German specialists. They decided to send the tank to Germany for detailed study. But the first surprises began right there in Africa. A German crew drove the captured Sherman over 350 kilometers across the desert to the port. The journey took 4.5 days, and each kilometer surprised the Germans more and more. The engine didn't overheat, parts didn't break, the tank just kept running without problems. German tankers knew that their own tanks often broke down even on short distances. But the American machine worked like clockwork in conditions where German equipment usually failed. The tank was loaded onto a ship and sent to Germany. The order was clear: the machine must arrive in working condition at the testing center near Berlin. In spring 1943, the Sherman arrived at a German proving ground. They gave it a German number and began detailed examination. German engineers measured every detail. They photographed all parts of the tank, checked every mechanism. And what they saw surprised them greatly. The Americans made the tank much simpler than the Germans. Where German engineers used complex solutions requiring precise adjustment, Americans applied simple and reliable designs. The transmission was especially impressive. In the Sherman, it worked almost like in a regular car. The driver simply shifted gears, and that was it. No complicated procedures. In German tanks, drivers had to learn special shifting techniques. This required time and experience. But a Sherman could be driven by someone who had simply driven a truck before. In June 1943, they arranged a special demonstration for Armaments Minister Albert Speer. The Sherman was to compete against the newest German tanks. The results spoke for themselves. The Sherman easily climbed a steep slope. The engine ran smoothly, gears shifted seamlessly. The new German Panther managed the climb, but with great difficulty. And the heavy 65-ton Ferdinand stalled halfway up. This was humiliating, especially in front of high-ranking officials and factory directors. Later, Speer wrote in his memoirs, the Sherman climbed mountains that German experts considered impassable for tanks. In late June 1943, a German newspaper published an article about the Sherman. It called the tank a worthy product of American industry. They noted the Americans' ability to mass-produce such equipment. Of course, the article was careful. They couldn't appear defeatist. But between the lines, anxiety was evident. American tanks turned out to be better than expected. Testing continued until autumn 1943. The Germans checked everything: how long the tank could run without repair, how the engine worked, and how reliable the parts were. The results were impressive. The Sherman could travel over 2,000 kilometers before major repair. This was 4 times more than early German Panthers could manage. Sherman parts rarely broke. And if something did break, repair was simple. Any mechanic with basic skills could replace a part with ordinary tools. With German tanks, everything was more complicated. Many repairs required special equipment and experienced specialists. By the end of 1943, German engineers understood the main reason for American success. The USA had an enormous number of automobiles. Millions of ordinary people drove cars every day. American companies had been mass-producing automobiles for decades, cheaply, quickly, and reliably. In Germany, automobiles were rare. They were a luxury for the wealthy. There was practically no mass car production. When the war began, Americans applied their experience of mass automotive production to tanks. They made tanks the same way they made trucks, simply, reliably, with parts that were easy to replace. The Germans had no such experience. They made tanks as unique military machines, complex, precise, requiring special. The numbers were merciless. In July 1943, during the major battle at Kursk, only 16% of German Panthers were operational. The rest stood broken. More tanks went out of service due to breakdowns than from enemy fire. By December 1943, the situation improved slightly, to 37% operational tanks. By May 1944, they reached 78%. But even this was worse than the Sherman achieved from the very beginning. Operating restrictions. German tankers received strict instructions for the Panther. Don't shift gears frequently, it might break. Avoid third gear, it breaks most often. Don't turn while moving backward, this will destroy the mechanisms. Turn carefully in place. All these restrictions reduced combat effectiveness. Tankers had to think about not breaking their machine instead of thinking about the battle. The Sherman had no such restrictions. The driver could use it like a regular vehicle, without worrying about breakdowns. German reports revealed the main difference in approach. Americans made a tank that simply had to work. They sacrificed theoretical perfection for practical reliability. Their philosophy was simple. It's better to have a tank that works normally than a tank that's perfect on paper but constantly breaks down. Germans strived for technical perfection. They wanted the best specifications, the most precise mechanics, but they paid for this with reliability. Another important difference: Sherman parts from different factories were fully interchangeable. A transmission made at the Ford plant fit perfectly into a tank assembled at the Chrysler plant. This was revolutionary for tank building. In field conditions, you could take parts from a damaged tank and install them on another. No fitting, no adjustment required. For Germans, each factory made parts slightly differently. Formally, they were the same, but in practice, fitting was often required. This complicated repairs and spare parts supply. The Sherman engine could run over 3,000 kilometers with proper maintenance. The Panther engine barely reached 1,000 kilometers. This doesn't mean German engineers were poor. They were excellent specialists. The problem was in the approach and mass production experience. German engineers' conclusions. Internal German reports acknowledged reality. The Americans have decades of experience in mass automotive production. This experience gives them an enormous advantage in creating reliable combat equipment. We cannot compete in this area. The Sherman is designed so that an ordinary mechanic can service it. Our tanks require specialists with years of training. In a prolonged war, this is a critical difference. The simplicity of American design is not a flaw, but an advantage. A tank that always works is more important than a tank with better specifications that spends half its time under repair. Germans strived for technical perfection. They wanted the best specifications, the most precise mechanics, but they paid for this with reliability. Another important difference: Sherman parts from different factories were fully interchangeable. A transmission made at the Ford plant fit perfectly into a tank assembled at the Chrysler plant. This was revolutionary for tank building. In field conditions, you could take parts from a damaged tank and install them on another. No fitting, no adjustment required. For Germans, each factory made parts slightly differently. Formally, they were the same, but in practice, fitting was often required. This complicated repairs and spare parts supply. The Sherman engine could run over 3,000 kilometers with proper maintenance. The Panther engine barely reached 1,000 kilometers. This doesn't mean German engineers were poor. They were excellent specialists. The problem was in the approach and mass production experience. German engineers' conclusions. Internal German reports acknowledged reality. The Americans have decades of experience in mass automotive production. This experience gives them an enormous advantage in creating reliable combat equipment. We cannot compete in this area. The Sherman is designed so that an ordinary mechanic can service it. Our tanks require specialists with years of training. In a prolonged war, this is a critical difference. The simplicity of American design is not a flaw, but an advantage. A tank that always works is more important than a tank with better specifications that spends half its time under repair. The story of testing the Sherman in Germany teaches an important lesson about military technology. Technological perfection doesn't always mean victory. Reliability, simplicity of production, and maintenance can be more important than maximum specifications. The Sherman wasn't a perfect tank. Its armor was weaker than German tanks. Its gun was inferior to German weapons. But it was reliable. It worked, and Americans could produce them by the thousands. By the end of the war, the USA produced about 50,000 Shermans. Germany manufactured about 6,000 Panthers. The difference speaks for itself. Deep analysis of German engineers, the price of perfectionism. After the first and most obvious tests were completed, the German engineers moved on to a deeper analysis. They needed not only to see what the American tank did better, but also to understand how it was achieved. The investigation shifted from the proving ground to the drawing boards and metallurgical laboratories. The first thing that caught their attention was the metal. German tank builders prided themselves on their alloys. The armor of the Tiger or Panther was not only thick, it was hardened using complex technologies requiring precision and time. Examining the Sherman, the Germans discovered that the Americans often used steel that was less hard but more ductile. This steel was easier to produce and process, allowing large components like the M4A1's cast hull to be manufactured quickly and with minimal defects. Initially, the German engineers, accustomed to maximum hardness, dismissed this soft armor with contempt. However, they soon recognized its hidden advantage. When struck by a shell that failed to penetrate, the American armor would deform but rarely crack. By contrast, the overly hardened German armor, designed for perfect resistance to penetration, was brittle, and under a strong impact, even without being pierced, could crack. Such damage required complex field repairs or rendered the tank unusable. The Sherman, meanwhile, kept fighting. The greatest impression on the German specialists came from the principle of modularity. The Sherman was assembled from large, standardized units. If an engine failed in the field, American repair crews did not attempt to fix it inside the tank. They simply unbolted a few fasteners, removed the entire power pack, installed a new one, and the tank was ready for battle within hours. The damaged engine was sent to a specialized factory for repair. German tanks, especially the Panther, were designed so that replacing the engine often required removing the turret, a nightmare for field workshops. Each repair demanded special lifting equipment, numerous skilled mechanics, and precious time. During large-scale battles, when every tank counted, German vehicles piled up at repair depots awaiting complicated restorations. German reports from that period began to use a new term: operational readiness. They concluded that the Sherman had critically high operational readiness. While German tanks were perhaps more advanced technically, their actual combat availability was extremely low due to maintenance complexity. Of course, the German engineers could not ignore criticism of the Sherman's gun. The 75mm M3 was unquestionably weaker than the long-barreled 7.5cm KWK-42 on the Panther. The Germans used this fact for some internal consolation. However, even here they saw a lesson. The Americans paid great attention to the versatility and mass production of ammunition. Their shells were simpler, cheaper to produce, and could be manufactured in astronomical quantities. The Germans, striving for maximum penetration power, complicated their shell and propellant designs, slowing production. As a result, there were situations where, on paper, the Army had enough tanks, but not enough shells for intense combat. The Americans, by contrast, could afford to flood the battlefield with shells, compensating for the lower power of their gun with sheer volume and numerical superiority. The Sherman's engine, often the Continental Radial Aircraft engine, also became the subject of detailed study. The Germans initially considered such a solution unserious for a tank. But the mileage figures spoke for themselves: over 3,000 kilometers. The reason was simple. American engines ran at lower RPMs and had a larger safety margin compared to German engines, which were pushed to their limits for maximum power output. German engines, though technically advanced and powerful, worked on the edge. The slightest maintenance error or poor quality fuel led to breakdowns. The American engine, while less elegant from an engineering standpoint, was designed with enormous durability and tolerance for harsh conditions. In wartime, with maintenance done in dust, mud, and under fire, this was a decisive advantage. By late 1943, the analysis of the Sherman led to a deep crisis in the German military-industrial complex. The conclusions presented to Albert Speer were grim. Impossibility of catching up. One cannot instantly adopt experience developed over decades. Germany could not restructure its industry overnight to follow American principles of mass production. Goal imbalance. German engineers, obsessed with creating superweapons, built systems that limited themselves. The Panther was theoretically perfect, but its operational flaws, gearbox problems, maintenance complexity, nullified its battlefield superiority. The War of Resources. The Sherman became the symbol of victory through logistics and quantity over engineering perfection. The Americans, producing 10 tanks each with 90% uptime, were vastly more effective than the Germans, producing one technically superior tank that spent 50% of its time under repair. This realization triggered late-war German attempts to simplify designs, to create more easily assembled tanks. But by then, it was far too late. The Sherman captured in the desert became not just a trophy, but a mirror in which German engineering saw its fundamental mistakes. It revealed that in modern warfare, victory belongs not to the most complex machine, but to the one that is most reliable, easy to repair, and mass-produced.